So this problem, problem number 10.40. So let us say, so this says predict the major product of dehydration of acid catalyzed by sulfuric acid. So you have to write down the major product 1-hexanol. So you have 1, 2, 3, 4, 5, 6. This molecule you have. If you do dehydration, H plus heat, and H plus is coming from H2SO4, what will be the major product? So you have to write down the major product in this case, because a dehydration of alcohol is always carbocation is an intermediate, so you can have a rearrangement also. So let us write down the major product. Have you done this one? Okay. So what will happen? So you will first H plus will attack here, lose this one. So you will have 3, 4, 5, 6. So you have 6 carbon. You will have a plus charge here. Now this is a primary carbocation, because once you lose H2O plus, now this can basically rearrange. So if this carbocation rearranges, you will have positive charge here. So 1, 2, 3, 4, 5, 6. So positive charge you will have on carbon number 2. And now you can lose from H plus from next carbon, and then you can use a double bond between these two carbon. You getting? So if you lose these two, you will have 1, 2, 3, 4, 5, 6, and double bond somewhere here. Now this will exist as a cis and as well as trans both. Are you getting or not? Because this side CH3, this side this group, so hydrogen you have. So this will exist as a cis as well as trans both. So cis and trans you will have as a major product. Trans will be the major product because trans is more stable. So you have to write both cis and trans. You cannot write this. You cannot make a terminal alkene. You have to make an internal alkene. That is the rearrangement of carbocation. That is the important part of this case. Now let us say part B. So part B. So this was the part A. So part B, what will have? Dehydration of 2-hexanol. So you have 2-hexanol. This is easy. 1, 2, 3, 4, 5, 6. So you have 2-hexanol. Now in this case there is no point of rearrangement even. So let us write down the product. Yeah, in this case you will have a plus here. Now lose H plus from here because there is no point of rearrangement. You have a secondary carbocation, so you will have double bond here. So 2, 4, 6. 1, 2, 3, 4, 5, 6. You will have at this position double bond. Are you getting or not? So this is a double bond, and once again you will have cis as well as trans both in this case. Now let us discuss part C. So this part says a dehydration of 3-pentanol. 1, 2, 3, 4, 5. At position number 3, you have OH group. Now once again there is no case of rearrangement. You have either make double bond this side or this side. So you will have 1, 2, 3, 4, 5. So you can make a double bond this side. Once again you will have a cis trans. Trans will be major. Now let us discuss D. I think you are copying, so please copy fast. Now D part is 1-methyl cyclopentanol. So this is 1-methyl cyclopentanol. So let me write the structure of 1-methyl cyclopentanol. So at position number 1 you have methyl group as well as OH group. So this is 1-methyl cyclopentanol. So if you do dehydration, you will have a carbocation here. And now you cannot make double bond this side. This is a less branch alkene. You have to make a double bond this side. So once again, in this case, you will have CH3 here, and double bond you will get here. You're getting. Now let us say E. This problem is pretty easy problem. E you have cyclopentyl methanol. So you have a cyclopentyl group and methanol. So you have to have CH3OH, H, and then you have a cyclopentyl group. So this is your cyclopentyl methanol. If you do hydrolysis or dehydration, in this case you have to make a rearrangement. So if first you have a carbocation primary, and if you shift the hydrogen you will have a carbocation here, and then you have to lose H plus from here. I think you are able to understand. So in this case you have a carbocation and loss of H plus, you will have this, because you will get primary carbocation that you can rearrange. So finally we'll have this product. In this case the product will be rearranged. Are you getting? So you can write the product is coming after rearrangement. So rearrange product. Now let us say F. In this case you have 2-methyl cyclopentanol. So you have a cyclopentanol, and position number 2 you have a methyl group. So let us say this is 1, this is position number 2. So this is 2-methyl cyclopentanol. Once again, if you do dehydration, you will have plus. Now you have to shift hydrogen, you will have a carbocation here, and then you can make double bond this side or this side. There is no problem. CH3, and then you can make a double bond here. Now in this case again the product is rearranged. Are you getting? So this is a rearranged product. So product is rearranged. Are you getting or not? So this is again a rearranged product. So you see we have discussed some of the dehydration reaction. In case of dehydration, product in some cases will be not rearranged. In some cases product will be found only after the rearrangement. So some cases product will be rearranged. In some cases product will not be rearranged depending upon the carbocation stability. If the carbocation that is formed is not tertiary, not secondary, then there is a chance of rearrangement. If there is a carbocation form is generally tertiary, there is a very less chance of rearrangement. So let us copy this one, then we will go for the next problem.